Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good evening, ladies and gentlemen. I will present my research entitled Experimental and Simulation Investigation Savonius Turbine, Influence of Inlet-Outlet Ratio using a Modified Speed Shift to Improve Turbine Performance in the International Conference on Energy Storage Technology and Application. My team research, my name is Yusuf Lambang, and the team research Supriyo, Putih Prasetyo, Toto Prasetyo, Abdul Syukur Al-Rozi, and Fatah Arifin. And also, I have some students to have the research. This is background my research. You know that nowadays the demand for fossil fuel energy has increased. Also, alternative energy resource to prepare for eventual integration of fossil fuel energy resource like wind energy, solar energy, fuel cell, and environmentally friendly alternative energy that has a high potential for development. This is some background in my research. So the Savonius turbine as a device that convert wind energy to electrical energy. It is simple, at a low cost, and also low wind speed, and we can apply it in also of wind from all direction. This is some advantage for Savonius turbine. This is my research. Before we have source reference in the researchers. From researchers patent by Sadaaki, Japan patent, and then also from Samsung, type Savonius, and also from Sulaiman. Savonius L produces low rotation and high torsion. And some reference from Ali is from Savonius turbine have flowing into the concave lead force and the rotor to rotate around the axis. And I choose my research with entitled Experimental and Simulation Investigations of Savonius turbine and Inlet-Outlet ratio using modified speed shift to improve turbine performance. The objective of my research to improve performance of the wind with modification of the Savonius turbine. The first literature study and design structural model we make and we analyze, we get the data from the test Savonius turbine, and finally we have result and discussion to conclusion. Study characteristic of the blade combination on the Savonius wind turbine U and IL type. The material and method. This is Savonius wind turbine. We made a diameter of 650 millimeters and height 600 millimeter with a blade cover and blade at the top and bottom rotor. The diameter shaft 1 inch in the middle of the turbine blade. We have some different ratio inlet outlet 2 and 2, 1 and 1, 2 and 1, and 3 and 1. This is also the single blade to analyze. This is material and method. This is single blade. This is 1 and 1 ratio, 2 and 1 ratio, and 3 and 1 ratio. But they have the same diameter of Savonius rotor. This method, we have some equation from the soft research. Is wind power, mechanical power, coefficient power, tip speed ratio, battery power, and system efficiency. And also we have method to get output this research. Use voltage current power algorithm in this process. First, we have literature study and we make design structural model, input, initialize Initialize air density, rotor sub-area, line velocity, and mass flow rate. So fit model, and then validated model. In this version on Vergen, pressure, wind velocity, power coefficient, torsi, tip speed ratio. If not convergent, we collect new data and apply this flow in the flowchart diagram. But if convergent, we can display the result of this program like pressure, wind velocity, voltage, electric current, wind power, current, turbine power, and electric power, also the speed ratio, efficient power. This is wiring diagram in my research turbine Savonius. The wiring diagram shows a series measuring instrument for voltmeter, ampere meter, generator, and load. This is generator, voltmeter, ampere meter, and this is load for the Savonius rotor. We have 5-watt load is added gradually and record the required parameter by increasing the 5-watt load gradually until the light flashes and the current saturated in this testing and collect my data. This is the results and discussion. Characteristic turbine rotation and power turbine, and this is curve of electric power and rotational speed of generator. The best results for the turbine blade is a single blade type with mechanical power of 4.4 watt and turbine rotation of 130 RPM. The lowest performance in double blade 1:3 ratio. They have mechanical power 3.3 watt and turbine rotation 125 RPM. And then this is characteristics of turbine versus torsi. This is characteristic of electric power versus system efficiency. Result my study, turbine with the best performance, also single blade turbine with torsi 0.3 to 4 Newton meter and mechanical power of 4.4 watt. And then the lowest performance of the rotor is a blade, double blade, 3:1 ratio. We have 0.253 meter and mechanical power 3.3 watt. The higher the turbine torsi value, the greater the turbine power generated in study Savonius rotor. This is also the sum wind speed. We have 3 meters per second, 5 meters per second, 7 meters per second, and 9 meters per second. But in the wind speed of 5 meters per second, single blade turbine has the best performance. With coefficient performance is 0.9 and tip speed ratio is 0.926. And then the growth of voltage, current, and electric power. Voltage, current, and the power. The single blade also has the best performance with voltage is this is 10.2 volt and the current is 0.34 ampere. This graph, this curve shows that the relationship between voltage and current is inversely proportional. When the generator is loaded 5 watt, the voltage value will decrease. Otherwise, the current value will increase. The more the load is carried, the voltage value will also decrease, but the value of the current flowing in the circuit will increase in the study Savonius rotor. Just simulation modeling for Savonius rotor bit with velocity, single bit, 1:1 ratio, 2:1 and 1 ratio, 3:1 ratio. Yeah, this is single 1:1 to 1:3:1 ratio. Yeah, Savonius U produce a large rotational speed while the torsi tend to be small. However, the Savonius L produce low rotational speed and high torsi at the same wind speed. This is some color. There are red color, blue, green, yellow. This is state the velocity with along bleed and Savonius rotor. Also, this simulation modeling Savonius rotor with pressure, single bleed, 1:1, 2:1, and 3:1 ratio. And the results, the Savonius turbine capture less wind energy than other lift turbine of the same size, since the energy received by the blade is actually used to push the convex blade, resulting lower efficiency for the Savonius turbine. Also the same, this is some color, red color, green, blue, yellow. This is also state pressure along with the blade from Savonius rotor. And the conclusion, my research, the first, the Savonius model blade wind turbine model has a diameter 600 millimeter with a turbine height 650 millimeters. The ratio of the wind inlet outlet, the gap, 1:1, 2:1, 3:1. And the test carried with variation in between speed of 3, 5, 7, and 9 meter per second. The second, based on the test data at wind speed 3, 5, 7, 8, 9 meters per second, the highest rotor rotation was found in the single bleed model, have 186 RPM, then followed 1:1, 2:1, and 3:1 double bleed. The presentation is the data table, the best test results from wind speed 3, 5, 7, 9 meters per second. This is, we have bleed single bleed, have coefficient power 0.24, and system efficiency 4.19%. Double bleed 1:1 have coefficient power 0.15, and so system efficiency have 2.03%. For the double bleed 2 and 1 have coefficient performance 0.1, also system efficiency 2.42%. And finally, double bleed 3:1 ratio have coefficient performance of 0.2, and then system efficiency have 2.23%. Then my present is this. Thank you for attention, and thank you very much.